talking about building a virtual lab, basically, or we'll kind of say this before we say it's virtual, building a learning lab. The target topic is for IPv6. And the idea of this was to build your V6 learning lab for free. A couple of ways I got to this point. Actually, in SharkFest a couple of years ago, a lot of folks were asking me about the environment, which was mostly virtual, that I was using. And we actually threw together a little time slot and found a room, and I just had a little impromptu talk on the last day about it, nothing formal at all. A few months ago, I was approached by the U.S. Federal V6 Task Force, who I give a presentation to once to twice a year. And they were talking about, we've got a lot of people that need to learn about IPv6 with all the new U.S. federal mandates of thou shall now be running V6 in increments of time from turning it on to full single stack environment. And a large part of it is people need to learn the protocol. And in that effort, just reading about it is, at least in my opinion, not the only way to really be learning it. It's certainly good to read a little bit about it, but it's really something you need to play with, get your hands in. And it takes networking gear, and it's not that it takes a lot of gear. In fact, you don't even really have to have true networking gear. You could do it with a couple of computers, but still, it takes a little bit of work to get it up and running, not just to the point of you can ping 2 or more devices, but to actually look at the protocol, explore in the protocol, run some tests on the protocol to understand how it's going to operate. And so this whole concept of this, let's build this lab for free or low cost. But I came to the point of you could do this, quote, for free. Now, for free has a little bit of a caveat. We'll talk about that. So again, I'm Jeff Carrell. I play with V6. I've been involved in V6 steadily for 11 and a half years-ish now, in all kinds of different modes of operating. And I certainly love to talk about IPv6. And so thanks for letting me do this afternoon or today. I have to say, maybe not everybody's afternoon, but this session. And I hope you have a good time watching through what we're going to talk about. And so again, this is really about building a low cost, and I came to a no cost with a caveat, all right, of building your own little learning lab. You're going to need a computer. Now, with that in mind, we're going to also target this to be a virtual system or a virtual lab environment. And this is actually nothing really new anymore. We've been talking in and around virtual lab for all kinds of learning for lots of years now, but it's still one of those things. If just trying to get into it, what are the parts and pieces? What is it that you're trying to do? And again, even though my presentation is kind of a focus on, I want to learn about IPv6, and so I'm going to target everything about it, the actual lab environment, you could do it on. You could use it for anything. You could use it for InfoSec if you want to get into learning about pen testing. You could do it for other protocol investigations, just to be able to see some things with Wireshark. And there are some of the aspects of this particular environment that I'm going to show you lends itself really, really well to being able to get packet captures on interfaces sometimes that you can't even do in a physical world, or that there's very much challenges in doing it in a physical world. Even if you've got everything sitting in front of you, it's sometimes a little bit of a challenge. But in this virtual environment, it actually works out really, really, really cool. So you need a bit of a computer, and you could get by with a small virtual lab platform with basically like a dual core processor, 8 gig of RAM, and probably even 120 gig of storage, maybe even less than that. Just really depends on all the different files and operations in this virtual environment that you're going to need. Now, I'll also give it another bit of info, and I apologize I didn't get it to the slide. It needs to not only be a computer that meets some of those specs, and we've had computers and laptops, desktops that have met that kind of spec for a long time. However, there's One more caveat that comes into play here is that the hardware needs to support virtualization, one, and two, as an additional component for virtualization, it actually you want it to support nested virtualization. Sometimes you might see that listed as 64-bit capable virtualization. And I say this because in this process of pulling this all together, I've built an environment on a Windows laptop platform, on a Linux laptop, and I also pulled out one of my MacBooks, and a MacBook Pro. Yay, I thought this was going to work. Well, it turns out that while my MacBook Pro will support virtualization, because I've been doing virtual labs on it for years, it doesn't support nested virtualization. It's an early MacBook Pro 2010. And as it turns out, later 2010s and moving forward would have met the needs that I needed. So I couldn't actually build this on my MacBook like I wanted. Like I say, it'll do, first layer virtualization. I've got VirtualBox, I've got VMware Fusion on there, works just fine for those labs, but not the nested virtualization, which we really need now for some of this new work. But yet, I will say, even at that point on the MacBook Pro, I still can have IPv6 running. I can have a lab, and I can still do things VM to VM. Okay, it just didn't support some of the extra capabilities that I want to be showing you, and then the reason why they're worthwhile. So foundationally, you probably want something that's right at 10 years old or a little bit newer to be able to do all this. If you've got a little bit older laptop or desktop laying around, that might serve very well for the base purposes of building this little lab environment. So let's back up a step and talk a little bit about a lab. A lab network 15 years ago, or even 10 years ago, or even last week, if you've got gear laying around or access to gear, awesome. The problem with building the lab, say at home, is that it may take up some space, and this is going to depend on the size, of the equipment. You may not have everything that you want, so maybe you go buy, and there's a lot of gear available on the second market, eBay, Craigslist, and I would say the bulk of my networking gear came used. Some of it was already 10 years old. Now some of it's 15 plus years old. And yet I can still do a lot of modern day protocol operations on layer 3 switches, which is generally what I buy. But now you've got some money to invest. You got to have space. You've got to run power, and when you're running these devices, it's going to generate heat or noise, and so often it becomes one of those. Well, the lab environment I like to build is going to be too much. And very certainly, it often is going to be powered off when not used, and powered on, and then everybody's like, well, "Who just fired up the jet engines?" Depending on the models of what the gear is. If you look at it from an idea of a virtual platform, great. Lots of free resources to use in the virtual side. There are also some resources that will cost, and so we'll talk about some of that as well as I go through some of this. There's also lab environments that you can access remotely. And it has been very up and coming over the last, I would say, 5 years. Lots of virtual lab environments out there that you can subscribe to. Some of them have a flat rate cost just based on time. Some of them have it based on usage. Now you can get lab environments in the cloud, and same kind of thing. It might be just based on usage, i.e. Shut down those machines if you're not using them, because as they're on, you're paying by the second or by the minute or by the byte or the bit or the whatever. All right. And then some of them you buy a block of time, or you buy so many tokens, which gives you an X amount of time. And those are great options out there as well. And there's some of those environments that even offer some amount of free time, kind of get you started, or they give you limited functionality. i.e., yeah, you can build it up, but nothing will stay persistent. So when you exit and you come back in again, 10 minutes later, 10 days later, a year later, you're going to have to start over. So hopefully you've got all of your configuration files ready and you can get everything loaded in there really, really, really quick. So we're going to take all this again and say, well, how can I do this for pretty much no cost? We start thinking about going towards a virtual environment. We continue to have these choices, right? Which virtualization platform do you want to use? Do you want to use some additional emulation um, software in conjunction with the virtualization platform? These are some of your choices. We think about virtualization. You've got Vmware's family of products from free to cost. All right. You've got the Oracle VirtualBox, which is free and multiple platforms. And both of those vendors' products work pretty much on Windows, Mac, and Linux. And that's the really great thing about it. We start looking in here at this middle section. These are your simulator emulator platforms, and they give a bit more of a GUI front end to your lab environment. If you strictly just play with, say, a virtual platform, and we'll just kind of say it in VMware or VirtualBox, you're going to do everything manually. You're going to make your links between your devices. You're going to have to set those up. Those are all virtual, typically virtual interfaces, or even linking virtual to physical. But you got to build all that. I'm not going to say it's difficult. It's what we used to have only. But it is a very manual process, and there's no picture, as it were, unless you build your own picture, your own diagram, and say, okay, well, I've connected these to these virtual interfaces, and these addresses, etc. So those will do the job. But if you come in there with either Gns3 or EBNG, Dynamips, or QEMU, those give you some emulation and potentially some nice GUI front end, i.e. draw some boxes or lay out some boxes, make some network connections, and the back end does it for the virtual linkage. And so you don't have to go in there and make all of those links. And so they work out really, really nice, as well as give you a nice picture. You build it and it connects it, and you turn things on and it works. And we'll see some of that. Cisco's got a nice environment, the Cisco Modeling Labs, it does that as well. Basically a subscription environment, but it's got a nice, good front end, gives you access to their environment. And this becomes the other key. You want to build an environment. And again, I'm kind of focusing from a network aspect. So I need switches and routers. Well, a number of these vendors now have a virtual version, or even multiple virtual versions of their platforms. Yay! So you can bring up a Cisco router or a Cisco layer 2 or a Cisco layer 3 switch or an Aruba switch or a Juniper router, on and on and on. All kinds of vendors have them. Sometimes they will offer free versions of those virtual platforms. Sometimes in that free, it's limited. It's limited in either bandwidth or number of interfaces or time. And some of them may charge for their virtual platforms. Cisco is one of the ones that does charge. However, you can actually get one of the older virtual routers, not maybe as fully featured today, but it still does a lot of great work. And so you can get at least one for free. I do have that. It legitimately free, not find it out there, in the internet. All right, so that's kind of all fun with that. So those things start factoring in again in my aspect of a network lab. And so we start thinking about some of those environments. Drilling a little bit more down into a virtual platform, looking at the type 2 hypervisors. We're trying to make this really easy. So we're going to run one of these hypervisors on top of a host OS, whether again it's Windows, Linux, or Mac. Now, there's potentially some caveats when you get to this point of saying, well, which host OS. One, almost to say your choice, right? But it has now moved into the mode of, again, what's the hardware type? What is the capabilities? Sometimes it's even like in Linux, I found for VirtualBox, not all Linuxes will work. I started playing with a Rocky Linux host, and I could not get VirtualBox to work, even following all the notes out there. And it's not even considered to support a Red Hat or CentOS platform, and Rocky is a CentOS replacement. But VirtualBox supports Ubuntu just fine, and a couple of other flavors of Linux. So sometimes you may have to do a little bit more investigation. In the VMware side of things, you're a little bit more flexible in your HostOS platform. And in fact, I even fired up a recent beta release of Windows 11, and I took all of my virtual platform that I'll be showing you here and literally just installed and copied all the files over to the Windows 11 computer, and it worked perfect without any changes whatsoever. So I was really happy about that. It was on a known laptop that had already been running. In fact, it's swapping out the hard drives between Linux and Windows. And I'm kind of focused on a type 2 hypervisor as opposed to, say, going to a type 1, say an ESXi, only from an aspect of it's a little bit easier. And now it might be considered a little bit more portable that you can have in there. Sorry, team, I kind of look over at another screen to make sure that everything looks good. By the way, if I didn't mention already, feel free to drop questions in the question answer section. And if you do in chat, that's fine too. I'll kind of watch that as we're going through here. Because everything's going to kind of build all the way through this two-part session as we go through here. These emulators, I spent a little bit of time talking about the emulators, and they are a really nice add-on. It sometimes requires a little bit of work, and a little bit of understanding of what's going on. But once you get the emulator going, it really, really makes working with this virtual lab environment nice. Gns3 is a free application. It's been out there for a number of years. That's my favorite, the one I've got them all my time on. EVNG is a little bit newer, and they have two versions. They have a free version and a cost version, and it's not a lot of cost. It's a little over $100 a year, subscription based, but you get a lot more features with it. In the free one, you can't build as big of a virtual environment, and there's some operational characteristics that aren't available, but still, there's a lot of folks that have been migrating from Gns3 to EVNG as well, and a lot of the vendors are making sure that their virtual platforms support now both of these emulation environments. I mentioned the Cisco modeling labs. It used to be called Viral. When they updated it to kind of like their 2.0, maybe almost 2 years ago now, they renamed it to the Cisco modeling labs. It's about $200 a year, I think. And you can configure up to 20 of 6 different platforms of their environment. You can even run it locally, or you can run it remote on their environments. In all of these, again, I use Gns3 all my times there. I keep thinking I want to go try EVNG, but I just haven't done it yet. I haven't gone to it. What do I mean with these emulators is that you get a nice pretty picture. Well, I've got some examples out here, some that I used, have built, and some that I have snagged, pictures of different labs. Hang on a second, I was looking over here. All right, so some comments in there. So this is a particular Gns3 lab, and this a unique characteristic about this particular lab environment is that it was linking both Gns3 on the host computer as well as through a USB Ethernet adapter out to physical gear, as it kind of listed over here. All these switches on the right were physical gear coming into a common switch that was linked to the laptop. And then I had some Gns3 VMs running on that host computer, and I was actually linked to another laptop that was running virtualization and going to it. And all of this was just basically one network. So that is part of the capability in this virtual world, that you can link out to physical gear. And I'm hoping to be able to show that here in our second session. A couple of other examples of some Gns3 labs that people have shared their diagrams. And the other nice thing is some people, they share their lab configuration. So that's kind of fun. So where I'm going to be showing something relatively simple, there's people building extremely complex virtual labs, sometimes even doing full-blown proof of concept of a very complex configurations of systems. Another one, I think this was one a CCIE candidate was working with towards his CCIE certification. Another particular one that I was running on a project, and virtualization from an aspect of self-learning or team learning is really, really cool. And even in my day job as a network instructor at HPE, we use virtualization labs for some of our training. And this happened to be one that I put together on a specific customer project. So, really fun stuff can be done. Example of another lab, virtual lab that I work with on my V6 hacking demonstration. And again, all virtual environment, different host OSs, as you can see in here, and just pretty much a flat network. There's nothing really special to this particular one, but still a number of different operating systems and functionalities going on. Now, this particular slide view is a little bit different than the normal. And what I want to point out here is effectively kind of on this lower left section was a computer, a laptop running Gns3 with the VMware Workstation Pro, and very specifically with a virtual Aruba CX switch. On the same computer was running another virtual platform from HCL, which is the H3C Cloud Lab platform for Commware switches. And it is actually a front-end Gns3 specific to their design. So it's not the traditional open Gns3, it's a custom Gns3 front end, and it runs VirtualBox on the background. And the other bit that I was doing is that in all cases, these two virtual environments were on the same laptop, the same interface, so they were in the same network. And I was proof of concept showing that we could run our network management application IMC to manage these two different devices, the Aruba switch and the Commware switch, from one platform, even though they were different virtual systems, different virtual networks, because they were linked to the host. So there's a lot of stuff that you can do here and have a really, really good time at it. So let's get to this. What we're going to talk about. Sorry, I'm just sitting there looking again. Okay. We're going to build this virtual lab. You need your computer. We're going to build it on VirtualBox because it's free. Let me back up a slide real quick and talk about this for just a second. In the VMware platform, the VMware Personal Desktop platform, they have two versions of their workstation product, one called Player and one called Pro. Player is free. It works at a relatively minimal level. Minimal meaning you can't do a lot of extra virtual backend configuration, especially with the network adapters. I do that a lot. So while you could do some of these things with Workstation Player, it actually works better if you want free to go with VirtualBox. If you're willing to spend a little bit of money, then go with Workstation Pro or Fusion Pro, and you have a lot more flexibility in what you can do just overall. Okay. But again, this whole concept of this system was to be free. So we're going to use VirtualBox as our VM. We're going to use Gns3. I'm going to use an open source router called VOS. which came from an older product called Viata, which came from some folks who had been at Juniper and a few other vendors. Viata was bought out by Brocade years ago, and they went to a cost model and deprecated out the free open source. A team took it over and forked it over to now call it Vios. And recently, that team has now also made the product where it's a cost model. You can still get their free version, typically a few behind, or you can get the fresh one. You just have to build it yourself. I'm using an older one that does everything that I need and is still freely available. I've got some Windows clients. A lot of people say, well, Jeff, you've got Windows client and you've got the word free. Well, that's because Microsoft makes pretty much all of their OS platforms available as timed eval systems. And so your timed eval is typically, at least it used to be 90 days, sometimes the 30 days. And when they time out, they either won't work or they will only work for a bit. Like my Windows that I have timed out a long time ago, but they'll stay up for about an hour. And if I'm not happy with that hour runtime, then I'll just go download a new version, get it all fixed up with all the applications that I want and everything else, and go for another, I think it's now 30 days in Windows 10. You can get Windows Server evals as well. So you could still build this environment with a Windows client, not even using your host if it was Windows, and not having to go get a full licensed version. Just get one of their timed evals. Linuxes, all kinds of Linuxes out there basically for free. So I'm using a couple of different flavors of Linux. Again, been playing a little bit more with Rocky Linux and Ubuntu, Alpine, just a couple of different platforms of Linux out there. But everything here except for your host computer was for free. This is what we're going to work with. A kind of a core router in this environment. It's going to be connected up to the host laptop. Hanging off of this router are a couple of switches and some clients. So I've got pretty much on the left and right sides a Windows and Linux client each. And then I have a little Kali Linux connected in here to do some of my V6 attack testing. Part of that testing is to validate, operations of V6 to make sure I understand what's going to happen, how the host OSs are going to behave, especially when things on the network aren't quite going correctly from a V6 operation platform. So that's going to be the main part of what I'm going to show in this first session. We come back to part 2. I'm going to expand on that and actually bring in a few more other router products. So I'm going to bring in a virtual Aruba and a virtual Cisco, hang off some clients. Now, another really cool thing about this whole virtualization environment is that you've got a lot of flexibility on how you run all these different kinds of virtual devices, i.e., are they run under the Gns3 operation, or they run under just the virtualization host OS or a host application? Even to those ends, are they Docker clients, or built from ISOs, or built from other runtime, or are they running on your host? There's all kinds of flexibility that you can build into this. And I've actually done that on purpose in here. You can almost tell from some of these icons, like in the Windows and the Rocky clients, that's supposed to be a VM, to let you know that those are VM-based hosts. I'll explain more about that when I get there. You can see on this Ubuntu, and down over here in the lower right, this Alpine, they got the little whale Docker icon on them. They're actually Docker image hosts running. And so there's, again, other extra learning that you can apply in this virtualization environment. The other bit that I hope to do in the second session is to be able to show you linking from a virtual platform out to a physical world, out to a physical Cisco switch, and how that works. So this is how you can also grow, or maybe you occasionally come to some hardware that you would like to test, and you've already got this virtual lab environment all built. You pretty easily can connect it in. Now, that pretty easily means generally you got to get from that host computer out, whether you use the host network interface, whether it's wired or wireless, or maybe an additional like a USB to Ethernet adapter. I've got a couple of those plugged up to the actual computer that I'm running right now this minute, and that's how I link to the outside world. I keep my regular network connection for just that, regular net operations, and then I use these USB Ethernets for going to other physical lab environment. I'm going to say thank you for attending. We're not done, but I'm going to say thanks now, all right? Because I'm going to be talking about a lot of other stuff, and I didn't want to miss. And when the slide deck is made available in a bit of time, there's more information in here, just some V6 basics, okay? Because I'm not going to be covering all this stuff, but just a little bit about IPv6 and looking at it in Wireshark, talking about it. I'm going to be showing you some of this. In the Discord room, I put a link out to this IPv6 cheat sheet that I put together, or reference sheet, and I will put it now in the chat as well. So you've got it both places. Feel free to take that. Hope you find it of some use. And with that, last little bit on some V6 related books that are out there for some further learning. Okay, that's it. That's no more slides. So thank you for that. Now let's start talking. Let's start playing. So the first thing is I've got one virtual environment. I'm RDP'd into it. This is running on a Windows 10 host. And if we look at it, we can see something like here is my VirtualBox system. All right. And under VirtualBox, I've got my Rocky hosts, my Windows host, and some other, my Kali Linux, one of them down in here, my AOS, my Aruba CX switch, and some other components. Some of these are related to this V6 lab and some are not. Now, the other thing is in this VM environment with Gns3 or EVNG, they also run a VM. And depending on then how the devices you're running in Gns3, they're either running inside the Gns3 VM or they're running on the host VM platform, in this case, VirtualBox. So those two Rockies that I was pointing out and the two windows that basically have that little VM symbol in them, they are these virtual machines over here. But I can actually do a little bit of control, i.e. start and stop these things. In fact, right now I've got this Rocky 2 over here that's not on. So a couple of things I'm going to talk about here in a flurry is with this graphic environment, again, you can build a nice picture, you can put in some great labels. The probably biggest great feature is that I would like to get a trace of the traffic of goings on. And in Gns3, on any particular of these links, if you right click on a link, brings up a submenu, you can say start capture. Behind the scenes in a Gns3 configuration, you can configure your applications. Where is it? Miscellaneous? Nope. And it does it automatically. That's why I can't find it. Oh, it does it when you do the install. My bad. It doesn't even show it in here as Wireshark, but it's going to, when you say capture, start a capture, it's going to, in my particular case, load up Wireshark. But the really important part is it's taken this virtual interface and via the APIs within Wireshark, bringing that in as an on-demand interface, because it doesn't physically exist. So Wireshark can't find it. It's going to run a Wireshark on this host computer. This becomes one of the, I'd probably say, in my opinion, top features of the emulation systems, be it Gns3 or EVNG, is that you can get traces on any particular link. And so I'm going to go ahead and start that because I want to see some of the traffic light up when I fire up that one particular client. Now, the other thing I'm going to do here in this Wireshark is I'm going to go ahead and execute my display filter for V6 because I want to go strictly from that perspective. And in fact, in a few of these networks, I may have a little bit of V4 configured, but I'm not running IPv4 as an on purpose. You might even notice that I'm RDP'd from my computer here to the computer 2 feet away from me on IPv6. So I run a lot of V6 in my own network. So I'm going to fire up this client. Now let's talk about a few other things. I've got this router in here, this VOS router. It's already configured. It's got 3 interfaces. I've got different V6 addressing configurations in it, i.e. on the ETH0 going up and the ETH1 going left, I've got Slack configuration, which means the router is going to provide the network prefix and the clients are going to self-derive their own interface ID or host ID. On ETH2, going over to the right, though, I've got DHCPv6 configured in the router advertisement, which means that the clients are going to be told to go ask a DHCPv6 server for an address because I'm just your router. I'm not going to do anything else for you other than tell you you should go ask a DHCPv6 server for an address. Oh, and by the way, I'm the VOS router. I'm also a DHCPv6 server, so I can help you out still. Yay, I don't have to have one somewhere else in my system. So I am going to, or I've already put on Wireshark. You see a little magnifying glass in here. I know it's a little hard to see, but hopefully you can well enough. There's a little magnifying glass which tells you you're watching, you know, you're in the environment. And there's like nothing going on right now. Not much of anything. Oh, look, a packet. Now, if you've seen any of my other presentations, I do color some of my packets for specific protocols, very specifically in the V6 environment. Red, as I see it here, is a router advertisement. Router V6 enabled interfaces should, and if they're configured for being the router, all right, should send out a router advertisement, which is basically, hey, I'm a router, anybody need me? And it will do it on a periodic basis. All right. And in my lab, I've tuned that periodic basis to be really periodic, like every 60 to 180 seconds. I expect to see a router advertisement. So even though I don't have any other devices actively running on this network, I still should see that traffic going out. We do. This is great. Last little bit. Let's go look inside this packet. And there's a few flags that we need to see. One is this prefix information, which says, here's the network prefix. But there's a particular flag called the A flag, or the autonomous address configuration flag, that is not set, which means I'm not going to tell you anything about your network other than I'm your router. There's another flag up here called the M flag, stands for managed address configuration. That tells the client operating system, go ask for a DHCPv6 server. So as we start firing this thing up, we should start to see some additional V6 traffic starting to fly around in here. And oh wait, I didn't want to do that. I wanted to start the client, start my client. And this is where we kind of go into wait mode, right? We're going to watch this pop up. This Linux VM, you might have noticed they fired up over here in VirtualBox. So that was Gns3 talking to VirtualBox saying, hey, fire up, you know, light up, turn on, power up. And so we did. And we're expecting Rocky to come up, get rid of those little screens. And as soon as the rest of the OS starts coming up, we should start seeing some packets. This is the learning lab bits right off the bat. Pardon me, in just a few steps, we can get configurations going. And I'll show you a little bit about that router configuration here in a minute. Let's let this go. We see another router advertisement just went. Pretty soon, I expect to see a pink packet. An IPv6 enabled interface, as it comes alive, should send out a router solicitation message. And in my world, those are pink packets in Wireshark. And that basically says, hey, are there any routers on this network? And the router should, if it is configured correctly, should automatically then respond with the router solicitation, not just everybody wait for the next one. All right. Now, I didn't see anything. That's not good, but I actually happen to know what's going on. In this particular host, the network comes up off. So if I enable the network, I should start to see a flurry of traffic and connect. So enable it, connect. Now we start to see some traffic automatically. All right, and look at that. Already we started seeing the packets that I wanted to see. The first thing that happens in V6 world is every interface must validate that that address is good to go. We call that the DAD test, duplicate address detection. And right here, we'll see that it's saying, I've self-assigned my link local address, and I'm basically going to do a neighbor solicitation to myself. As long as nobody answers, I can use that address. Then it's going to send out this router solicitation message. Any routers out there? The router says, yeah, here I am. The next thing that happens, the client sends out a solicit. Hey, any DHCP-V6 servers out there? And one replies. It happens to be the router replies. All right, you look at the last hextet here, a 502. We saw that in the router advertisement right there. All right, so the router acting as a DHCP-V6 server said, yeah, here I am. And we expect to see then the client to say, well, okay, may I have an address, please? And the DHCP-V6 server says, why, sure, let me give you an address. Let me look at my pool, blah, blah, blah. And sure enough, I'm going to give you this address. So now we can come over here to this client, bring up a terminal. I'd be still long enough. Here we go. Click, click. And now this is where you start becoming aware as you add a lot of devices. And I don't have that many devices on, and it's not really a problem. But at some point in time, you become aware that that maybe a little bit older, a little bit less capable computer is not working as good for your learning lab as you might like it. And then we can see on in POS3, and I think I've got just one right here, and we can see that it was assigned to 2001 DB8 6 lab 1010 109. Another little bit of tidbit, if you're not as familiar, 2001 DB8 is a reserved address for documentation /labs, meaning it is not routable to the outside world. If you try to route it, the upstream should block it. If they try to send it to you, you should be blocking it. All right, but it is completely routable within your domain, no matter how big your domain is. All right, completely routable. So I am fixed in my first two hextets. My third hextet is 6 lab for all of my work. My fourth hextet is my network. And then we're down to the last hextet as my host address, 109. So let's go look at the router right quick, the VOS router. Let me show you a little bit about its configuration. So VOS is an operating system. It's not exactly Cisco iOS. It's not exactly RuboOS or RuboOS CX or not exactly like any of them. It feels a little bit like FortiOS. It feels a little bit like Junos. Only because those are all derivatives of each other. Well, probably all derivatives of maybe Junos and other OSs. So it's a very hierarchical in its configuration operation. But if you're willing to spend that little bit of time to learn it, it will do tons of stuff. And again, it's free, and it's not a heavy OS running. So this ETH0, the one that goes up, we can see a few things. It does have a V4 address. It does have a V6 address. And all of this component in here is its V6 operation. all right, for it to be a router. In this particular case, we see the network prefix. We see the A flag is on that network, and that the M flag is off. So that was another one of those networks that's doing slack. We see another particular config line here that send advertisements is true. We want to send router advertisements because we're a router, and that's okay. We look at the ETH1, that's one that went left, and it's also configured for Slack. Here is the quick eyeball things. All right, not only did we know that or could see that in Wireshark really easy, but in the configuration, if the A flag is on, the router advertisement is going to be configured to provide the network prefix. You then expect to see the M flag off. Well, let's say you're early in your V6 journey and you fire up a V6 router and you read through the documentation and it says, if you want to do DHCP-V6, you need to enable or turn on the M flag. And so you go do that. What it probably didn't tell you right there to say, and you probably want to turn off the A flag, because now what's going to occur is the OS is going to get multiple V6 addresses in the same network prefix. While that's completely operationally legal and there's nothing wrong with it, you don't generally want that. All right, this is where the learning lab and starting to go through the protocol, it's not just about turning it on, it's about understanding its operations. All right, so we look through here, we see this ETH2, which is what I've just been working with, and we see the A flag again is off. We saw that in the protocol decode, and the M flag is on. All right, so again, you can't say those are mutually exclusive because they will both work, but you don't generally want them both on. But those are great things to go play with in the journey of the IPv6 journey to see exactly what's going to occur. And then what happens at the clients when these kinds of things happen. Some of the other bits that I've got in this configuration in here, I actually have a fourth network, but it's not up and running right now. But give you a little look in here. It had the A flag on, the M flag off, but it actually has the send advertisement, or the router advertisement is turned off, because the actual next leg in that particular part of the network is going to two other routers. Routers don't typically need to send router advertisements to each other because everything's hard configured. So it's like everything else. If you don't need the traffic on the wire, turn it off. If you want the traffic on the wire, turn it on, and then work the operational aspects as well. Continuing the configuration. I've got some route statements in here. These actually feed down to that lower leg that we're going to have in the latter section. We can see the DHCP-V6 server config over here for that lab 1010 side of the network. All right, and we can even see the pool that it comes from. So a few other configurations, and that's pretty much it. With that all in mind, we finally go back to my diagram. I've got both these Linuxes up right now. Kind of while we're sitting here, let me go ahead and fire up this little Windows client, because I'm now getting down to time. Pardon me there. Let me look for questions. Oh, somebody was asking a question. I'm so sorry. OpenSense. OpenSense would probably be okay. I've not played very much with OpenSense at all, but my understanding is it probably would work just fine, at least for some basic. I've not used it in any kind of a production world, so I don't know about its security, but I know OpenSense has been out there for quite a while. V6 in a secure environment to itself. Yeah, sure, no problem. What's the deal? It's a protocol. It works. You know, I would say from that aspect of, you know, if you've not played with V6, you just need to play with it. Past that, the only other issues is the particular, say, firewall or router application that you're running. Does it support V6 appropriately? That's the world we have a little bit more issues in, just in general, in V6. How does the GNS3 lab? Okay, so let me show those couple things. That's a great question. So here is the where is the GNS3 VM? Here's the GNS3 VM. So the question was, what does that look like? Well, it's a VM, okay, and you pretty much don't do anything with it. It's all controlled and used by the GNS3 application. You can still get into it and do a few things. Say like you want to upgrade it. If you upgrade your GNS3, you got to upgrade your GNS3 VM. I've done those things, but that's about it. There's just, I don't even start and stop it with VirtualBox. It's all automatic with GNS3. So yeah, you still see it as a regular VM in this particular case. And some of my machines are going to be on that VM. So let's see, hiccups moving to Rocky. I can't say I've done much work with Rocky. We use it a lot in the day job side for some of the applications in HPE, but we haven't done any testing on it that I have. So let's see. You know, VirtualBox, VMware Workstation Pro, I buy Pro and I upgrade it every time because I like the additional feature capabilities. But this particular process over the last 3 months has taught me a lot more about VirtualBox than I ever knew before. So, but I still like VirtualBox or VMware Workstation better, just because more than anything else, you can do more back-end links with virtual and physical network interfaces, and I'm all a little bit more about that. So, kind of how we go with that. There's a bit about Linux, so let me talk about that for just a second. My only reasons for choosing a few of these different Linuxes is just for my own experience. Okay, I am not a Linux person. I use Linux where I have to. I learn what I have to. Google is my friend, and like I say, the only hiccup I had with Rocky in my own little world here is I couldn't get VirtualBox to work under Rocky. So this particular, or not this particular host, actually, I can show you this. I've got this whole environment running over here on Ubuntu. All right, and literally the same thing. The first screen, all right, so you can kind of see I've got 2 environments in here. Hopefully you will be able to see. You know, the one I've been showing you is on Windows 10. I built it first. Once I got all of that configuration built, I tried to bring up Rocky, and VirtualBox couldn't make it work. Brought up Ubuntu with Rocky GNS3. And again, I just copied all of my files over and built the exact same environment over here in Linux. All right, so that was one of the really nice things. When I built the Windows 11 box, same thing. I just took all the files, all the images, all the configurations, the whole bit, the VMs, everything, and just copied them over. That's kind of another nice thing about this virtualization world, is that it's very portable, you know, computer to computer, friend to friend, coworker to coworker. All right, so it makes it a lot of fun from that perspective. Kali, I don't use Kali as a, I would say, quote, Linux platform. I use it mainly for what I would call my troubleshooting, my testing, my attack mode. And that's probably just bad on my part. I probably should embrace Kali from all aspects, and I just haven't, okay? Nothing past that. And lots of people basically run Kali as their, you know, prime OS. Okay, so was a question offered on GNS3? Oh, sure. Well, I learned GNS3 over the course of a year or 2, okay? But I also picked up some tidbits from David Bumble is one particular gentleman who does a lot of different virtual training. He's got it on Pluralsight, Udemy, and some others. He's done GNS3 training, all kinds of Cisco training, all kinds of network automation, all kinds of security, just all kinds of training. Others have too, I know, but I've worked with David and have taken and subscribed to some of his courses as well. So there's a question that was made about when I powered on Rocky. So when I powered it on, and same thing with Windows, okay? It's not a wake on LAN operation. It's actually an API that GNS3 says, go VirtualBox, and it would have been the same thing as if I had, you know, like right click and started. All right. That's what GNS3 did to both these Rockies and that Windows. All right. It's not, they're not running in the background. This Windows 10 #1 is powered down. All right. I cannot get to it from any aspect. In fact, if you look at it compared to say this one, we see this is up and running. Win 2, my Win 1 is powered down. If I were to go ahead and start that one, then you'll see it move from powered off over here once the APIs kick in, and we see the window power came up, we see it running, and it's firing up, loading up. All right. That again becomes some of that value here of GNS3's operations, backend functionality. Now, not all these VMs are necessarily controlled, or let me rephrase that. Not all of these VMs are running under VirtualBox. Like this VOS VM is actually running under the Gns3 VM. That's where we call the nested VMs. And that may be a capability. It may not. As it turns out, my Aruba switch virtual system doesn't work in GNS3 VirtualBox combination, but it will work in just VirtualBox. But I can still bring it into GNS3. All right. So there are sometimes some little bits of caveats that go into all of this stuff. So what I'm doing is probably a little bit more, I would say, not complicated, but a little bit more advanced than if I were just to say bring up a couple of Linux hosts, but start small. I consider this environment small or small-ish, okay? Not huge, a few machines, a few different OSs, a router, all right? And what I was gonna show right here right quick was that this guy has an address, Windows 10. He's over here at 108. If we go back over to Win #1 and sign into it, and he is on the left side of our GNS3 world, right? So he's on the Slack side. What I know from my configuration is that a Slack address is going to be longer, i.e. not longer in the number of the 128 bits, but longer in its display. Almost every hextet is going to have a value, where in my DHCP, my 5th, 6th, and 7th hextets are all zeros, okay? And I do that on purpose. So this gives me a quote shorter address. It's shorter to the eyeballs and the brain, all right? Whereas we come over here and look at this one, it's going to be just display-wise a little bit longer. All right, 2001 DBA6 Lab 2000 or 201, and then we get all of this. So a few things. These two Windows hosts, different computers, all right, different networks. Look at the 4th hextet. With that in mind, and having a router fully configured for routing, I should be able to ping from Win 1 to Win 2. All right. So the test, right? It's always the test. 2001 DBA6 Lab. Oh, by the way, don't forget you can do hex words in your addresses. Don't in production. And there we go. And he can ping. So the router is working. All right. 109, I think, was the Linux host over here, the Rocky. Oh, where'd he go? Rocky 2. That becomes the problem with a single screen environment. Well, I won't call it a problem, but real estate. This computer that I'm actually doing everything on has 3 screens. And so I've got screens all over the place while I keep turning around and looking. But routing is working. This guy, if we look at Rocky 2, or excuse me, Rocky 1 down, where'd he go? Rocky 1, same kind of thing. He should be able to ping. Oh wait, who we ping already? 109. Oh, not that network. 1010 network. Colon 109. Oh, team 1010 ::109. Yay. So we're pinging Linux, we're pinging Windows, and the in theory is I should be able to ping back and forth. Only one thing that I have going on here is that I might not be able to copy paste between the VMs. I think I need to fix, yeah, I've got a configuration issue. But anyway, we can just, manually type it out. 201, and I'm getting close to my point and time for questions. So I'll do a little bit more talk. We'll go back through if I've got any other questions, and we'll take our break and we'll come back for part 2. But let me finish out this ping. So for Charlie Delta 2, 52 D4, 53 DE, and 6 Baker 08. Okay, so Windows are pinging back and forth. I would expect the same thing for the Linux is. The router is doing its job down here, okay? That we are seeing with some configuration, as they say, going on around it. And in fact, this host computer should or might be able to, let's go look at his configuration. He is configured for, let me see, wrong computer, not that host computer, this host computer right here that I'm on. You see, I've got some of my screens in different colors, different fonts, different backgrounds, the whole bit. You can kind of maybe see why I'm doing that. Okay, so I've got my little note down here saying that I'm on VirtualBox Network 4. All right, and I've got that bridge to the real world. And so we see that this adapter, this virtual adapter in this computer has this address. All right. And he's got a router. So these in theories are, I should be able to also ping those folks over on the 1010 side, 6 Lab, 109. And now, hello, why are we not pinging? 2 DB8, 6 Lab 1010. Well, isn't that just not fun? Okay. Well, we're going to blame it on the host. All my VMs could ping each other. I'm just not quite sure why the host is not pinging. I know the interface was up because I was doing some V4 work with it earlier. All right, so let's see if we can ping his default gateway, 2511::1. Well, he can ping his router. Can he ping one of the other routers? Got something else going on. I almost suspect this to be my particular issue, that in my table in here, my route table of this guy, I might have a, it's route parent, isn't it? A route, for some reason, not as specific as I probably need it. So V4's routes we don't care about, these V6 routes, because that computer also is connected on a public capable V4. Well, he knows about that particular link. So he should have a specific enough route, to go to it. So why he's not going past it, I'm just not quite sure, but at this point, that's okay. I'm not going to worry too much. I troubleshoot that later, as it were. But I sure suspect he would be able to get there okay. So, well, we'll bail on that little picture. Love the demos, right? Okay, where am I at on questions? Let's just see. Powered on Rocky. So I think we got Powered on Rocky, which was yes, yeah. Okay, so we got it wasn't Wake Online. Okay, we got that one. Gns3 classes probably might want to consider that. We think we got all the rest of these answered at this moment. Yeah. Okay, so I think I'm pretty well got those answered. Okay, nice, nice. The demo effect. Okay, so let's see. What else can I show here right quick? Since we got a few more minutes before our appointed break. All right, let me make sure I have my time right. And now I'm sure Miss Naomi will keep me straight on that. So we'll tell you what, we'll go ahead and fire this up. So let's do something here. Actually, let me show you a little bit more information on the configuration of GNS3. So go into Edit Preferences on GNS3. And one of the things that I can show you in here is if I want GNS3 to manage those VirtualBox VMs, I actually had to put that into my configuration. So I had to go in and say, I want you to talk and deal with the Rocky VMs and the Windows VMs, and actually it will the Kali. Oh, but wait a minute. How do we tell VirtualBox, or excuse me, GNS3 to even be talking to VirtualBox? Well, you come up here to this GNS3 VM configuration. All right, GNS3 defaults to talking to VMware Workstation or Player. All right, so what you end up doing is that you'll install GNS3, you install your GNS3 VM in, let's just say, VirtualBox for right now. All right, and then you fire up GNS3. You'll have to go into preferences and switch this to VirtualBox. It doesn't automatically know which VM platform. And then you say, okay, and then talking to VirtualBox, what is the VM name? Well, GNS3 defaults that name to GNS3 VM. I highly recommend don't change that, only because I have done that and I've gotten myself in trouble when I've updated versions, and then I couldn't get to the VM anymore. And then when I did, I had a corruption. Now, there quite possibly could have been all Jeff's problem. All right, I fully accept that. But I've just found in my travels, if I just kind of leave some of this stuff at the default, everything else works out just fine. Even on that VM, we can say how much resources do we want available. And because I know I'm not going to be running a lot of high-end VMs in my GNS3, I want to run them more over here in VirtualBox. I don't have a lot of resources, 8 gig of RAM, a couple processors. I could run a lot with that. So first off, we did that configuration in GNS3 to say, go talk to the VM. And then I configured it to say, now, once you're talking to the VM, the VirtualBox VM, I've got some machines over there that I want you to talk with. And as I look through here, I've got a VIOS 117 configured as a VM, but it's not in my table here. So I can actually add that real quick by saying new. It's going to be a VirtualBox on this computer. And it goes out there and it looks for all the VMs that I don't have already defined here in GNS3. And so there's that VIOS 117. So I'm not going to do that right now. I'm just kind of showing you. But that is the basic linkage of the API. And while there's not any kind of a wake on LAN type functionality, it's all truly APIs going back and forth. And so you can see all of these different ones that I have configured from this. You have the capability, if I had VMware running on this computer and had VMware VMs, then I could talk to them even if it's not the VM platform. We still have a particular way, and Docker containers. And you can see I've got a few Docker containers. So you can actually say, I want a new Docker container. I want to run it on the GNS3 VM. And then you basically say, what's your Docker image that you want? And you can see I pulled down Alpine, a Metasploit configuration that Lee Major, I forgot Lee's last name. Oh, I am so embarrassed. Anyway, he put that together and has it up in Docker repos, and I'll pull down a couple of Ubuntu's. The component there is this system has to have public capability to go out to Docker or be able to have a Docker repo in your own lab network, which is maybe another thing you consider. So once they're down and running, now they're Docker containers running in the Gns3 Vm. So you can do container play in this world as well. Yes, I want to quit without saving. So we'll fire up this one real quick. Just to get it started, we'll be able to see that this Linux, Kali Linux over here, I think it's the 2018. Yep, the 2018. Actually, I found I had some extra utilities already configured on that after I loaded a newer version of Kali Linux, and I just didn't go back, take the time, and reload all of my utilities. So I just brought up my older Kali, but you know, nothing wrong with all these things. Now, in this particular world, I may you know, have whatever all utilities I want, and one of the particular bits that we'll try to run through in the second session is doing some V6 attacking, because we want to see in this learning journey how V6 devices operate and react to V6 packets. You know, they appropriately configured V6 packets on that system and what they're going to do. I can't remember. Oh, I just logged in wrong.
Yeah, just a few more minutes.
Yep. So with that, let's see. Thanks, Delving. So we've seen now a couple of times of the VMs being controlled by Gns3 as far as powering up. We've seen some of the VMs in their configurations of talking. Let's go over here and look at this. We've seen the different Wireshark packets. Let me get into here. Oh, All right, I had some other configs there. You can see some of the tests I had done before. There we go, that's what I was looking for, ifconfig. Now we can see that this Kali Linux machine is actually playing correctly. I didn't expect anything less, but it is working correctly. You know, in this environment, we would have seen the appropriate packets. Let's see, ETH2, ETH2. Where did I have the network for? Oh, host only, ETH0. Did I have an ETH1? I may not have had an ETH1 in my Gns3. Oh, I did have an ETH. I didn't have it in the right spot. I had it down here at this client where I should have had it up here, the link off the router. We could have seen the Kali Linux come up, but that's okay for now. Just mainly to be able to show this kind of a functionality, a little bit of work. Yes, okay. This was probably about 4 hours at the base, so kind of getting things together, you know, bringing this up with probably another bit of time, you know, tweaking and tuning. And part of it is because I had all kinds of varying configurations. I had all kinds of VS configurations that I was able to draw from other projects. But you could, in a virtual environment, take just 2 virtual computers, 2 Linuxes, you know, 2 Windows, one of each, back to back. You know, or put them in a hub or put them in a switch. All right, just put them in a plain vanilla layer 2 connection point and fire them up, and just by default V6 will be enabled on most every operating system these days, and you would be able to play with V6 at a foundational level or whatever else. You know, take a couple of Kalis, take a Kali and a Metasploit, whatever it might be, and connect them up. But you can do lots of additional things, and it can continually grow.
Jeff, sorry to interrupt. We got to
Yes.
switch over, give people a break.
Yep. Okay, break. 15 minutes. We'll come back for part 2. Thanks, everybody.